So now we are recording this Zoom video conference for November the 21st. I'm going to my computer so it's a little easier. Can you still see everything?
I can, yes, sir.
If I flip everything around, I can write on it a little easier.
Okay.
Okay, so this is a Zoom video conference, November 21st. Here is the agenda. I wanted to discuss the final exam schedule and how to prepare, answer any questions anybody might have. And then I'm going to cover Venn diagrams and some logic items. And then I'm going to work some key problems on the practice final. How to prepare for the final exam. I would go back and work any homework or test questions you missed. Be sure anything you missed, you know how to work, and you can contact me if you have any questions. I think everybody has at least taken a look at the practice file on D2L. The password is EGSC. It did require a password when you did it. Is that correct? Miranda?
Yes, sir.
Oh, you did use a password, right?
I did, yes, sir.
Good. And there is an incentive for doing this. If you make 90, you can add 3 points to your final exam. If you make 80, you can add 2 points to your final exam. If you make 70, you can add 1 point. Also, you can work the final on my website and also check out the video in which I worked the other version of it. In fact, I'm going to go. I hope everybody can get to the website these days. If you go to the website and go to the quantitative skills and reasoning, this page basically has everything you need to know, including your daily schedule and all the Zoom videos and the videos that you need to watch. You can go to the final practice test right here. And here it is. And if you just click on the final practice video, I work all the problems. I would suggest you try to work all the problems yourself and then look at the video if you have any questions. And anytime during the next, gosh, what do we have, about 3 weeks or so before the final, you can contact me if you need any help. Okay, now I'm going to work some problems. First one has to do with sets. You got set A and you got set B, and you're asked whether or not 10 is contained in set A. Obviously, you don't see any 10, so it's false. You're asked whether or not B is contained in set A. And you see 1 is, 5 is, but not 6. So it's false also. Pretty simple. Now, we're looking at sets again. We have set A, set B, and this symbol is A union of B. It basically means you want to take A U of B is everything that's in either A or B. And the best way to do this is just look and be careful. Starting with 1, I see a 1, a 2. I don't see a 3, but I see a 4 up here. Don't see a 5, but I see a 6. See a 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But don't put 19 down because it's not in either one, but you do see a 20. So this is a union. And then you list the elements in the set A intersection of B. And this set has to be, any numbers you put here has to be in both sets. And the easiest thing to do is start with the smallest set and see what's common. And you immediately see that 6 is, 11 is, and 17 is. So there's the answer there. Now we have another set problem. The U set is AB all the way to J. That's a universal set. And then you have A is C, G, H, and J. And you see B and you see C. So we want to determine the intersection of A and B union with C. So the A intersected with B look at the elements that are common, and that would be C and G. And then A intersected with B, union of C is going to be C and G union with C, which is F, G, H, I. And this is going to contain all the elements, and that would be C, G, F, H, and I. You just have to be careful and make sure you haven't missed something. Now in the Venn diagrams, this one is fairly simple. You got 87 pet owners. 48 say they own a dog. So within that circle, there would be 48 pet owners. They're the ones that own a dog. And 11 say they own a cat. And 3 said they own both a dog and a cat. Well, that would be the intersection of the two circles. And you want to know how many own neither a dog nor a cat. Well, we need to fill out the other. We got 45 here, since the total dog owners are 48. And we got 8 here. So how many own neither a dog or a cat? Well, that's going to be 87 minus 45, 3, and 8. Those are the total that own a dog or a cat, which is 56. So the number that that own neither would be 31. So the answer is 31. Another similar problem, you have 152 pet owners. 70 own a dog. 58 said they own a cat. And 11 said they own both a dog and a cat. That would make the total number of a dog but not a cat would be 59. That's obviously 11 subtracted from 70. And you don't even have to fill in the rest. How many own a dog but not a cat? It's 59. And of course, you could fill out this other part, and that would be 47 if you wanted to know the ones that own a cat but not a dog. Another survey, you have 17 pet owners that own a dog, and 7 did own a cat, and 12 own both. And you want to know how many own a cat but not a dog, so we need to figure out what's in the other part of the circle, which would be 70 minus 12, which is 58. So the answer is 58. Now the next one is a little bit more involved. You have to draw 3 circles in your Venn diagram. You've got folks who watch Netflix, Redbox, and Video Store, or either get their videos from these vendors. 58 use only Netflix. That means that this part of the circle is 58. 44 use only Redbox. And 22 use only a Video Store. 9 use only a Video Store and Redbox. That would be this part right here. 9. Let me erase that. And 59 use only Netflix. And Redbox. So it would be 59 here. 25 use only a video store and not Netflix. That would be this group. And 15 use all 3. So that would be this portion of the Venn diagram. And you want to know how many people use Redbox? Well, that would be the total circle, which would be 44, 59, 15, and 9. If you add all those up, you get 127. Okay, that's it for Venn diagrams. Now we're going to talk about logic. The first couple of things we talked about logic was and or. And I'm just illustrating this with a little diagram. Why in the world would you want an and or an or kind of function? Suppose you wanted to know what you had to, the requirements for sending an EMS person to respond to some kind of emergency. First of all, you have to have an EMS person. That would have to be true. and have an emergency call, it would have to be true. Both of them would have to be true. If that's true, you send EMS out. Notice you could have another required input that you have supplies. Or you could have some other requirements. Now, suppose you wanted to figure out what you have to prepare a meal. Well, you could have a chicken or you could have beef. Either one of those would allow you to prepare a meal. If you had both of them, you could prepare. If this was true and this was false, you could still prepare something. If this were false and this were true, you could prepare something. But if you had no chicken and no beef, you couldn't prepare a meal. Okay, now we get into conditional statements. And when we write these in plain English, it makes pretty good sense. Sometimes the notation, you have to think about it a little bit. A conditional is a logical compound statement in which a statement P is called the antecedent, implies that another statement Q called the consequence. It's written as if P then Q, and it's translated if P is true, then Q is true. The consequent is a thing that follows another. I say consequence myself, but the textbook says consequent. A conditional asserts that if the antecedent P is true, its consequence Q is also true. Really important thing to understand, any conditional with a true antecedent and a false consequent must be false. Sometimes it's easier to understand these if you have examples of P and Q. The English statement, if it's raining, then there are clouds in the sky, is a conditional statement. It makes sense if the antecedent, which is P, it is raining, is true. Then the consequence, there are clouds in the sky, must also be true. Notice you would never see rain occurring unless there were clouds in the sky, although you could have clouds in the sky and not have any rain. Notice the statement tells us nothing of what to expect if it's not raining. There might be clouds in the sky or there might not be. However, if the antecedent P is false, then the consequent becomes irrelevant. So let's look at what we call a truth table. In traditional logic, a condition was considered true as long as there are no cases in which the antecedent, which is P, is true and the consequence is false. If Q is false, then the conditional is obviously false. So let's put a truth table together. Now, the conditional statement P, if P then Q, is saying if it is raining, then there will be clouds in the sky, or there are clouds in the sky. We're evaluating if P then Q, is it true or false? Well, if P is true and Q is true, it's saying it is raining and there are clouds in the sky. That's true. If we evaluate P being T and Q being false, we're evaluating it is raining and there are no clouds in the sky. That's false, because you never see a case when if there are no clouds in the sky, it's raining. Now, the last two requires a little explanation. With P being F and Q being true, it's saying it is not raining and there are no clouds in the sky. we call that true because there is no evidence to contradict the statement. And if P and Q are both false, it is not raining and no clouds in the sky, we say that's true. There's no evidence to contradict it. And sometimes it's a little hard to put your mind around, but if the antecedent is false, we cannot prove that the statement is a lie. So the result of the third and fourth rows is true. You are innocent basically until proven guilty. Is another way I say it. Okay. Now we've got 3 more definitions related to conditional statements: the converse, the inverse, and the contrapositive. The original conditional is if P then Q, that if P is true, then Q is true. The converse is if Q then P, which means you just reverse and say if Q is true, then P is Q. Now notice that this may or may not be true. P implies Q may be true. But Q being true may not imply P. So the converse, if there are clouds in the sky, it is raining. That may or may not be true. But you know for sure if it is raining, there are clouds in the sky. Now the inverse is if not P, then not Q. That again may not be true. A statement with respect to the rain would be, you would say, if it is not raining, there are no clouds in the sky. Well, if it's not raining, it could be sunny. So this is not necessarily true either. But always the contrapositive is true. If P implies Q, then not Q implies not P. And with respect to the clouds and the raining, it would be saying if there are no clouds in the sky, it is not raining. And this slide basically says the thing I just said. Now we have something called a biconditional. A biconditional is a logical conditional statement in which the antecedent and consequence are interchangeable. In other words, P implies Q and Q implies P always is written P with the double arrows are pointing in, at Q and pointing at P, and it's translated as P if and only if Q. So if P is true and Q is true, then the biconditional is also true. However, if P is true and Q is not true, it will be false because they both have to be true or they both have to be false. And I'll give an example in a second. If P is false and Q is true, then the biconditional is false. However, if both are false, then that is true. So a biconditional is considered true as long as the antecedent and the consequent have the same truth value. That is, they are both either true or both false. So here's some examples of a biconditional statement. Notice the one about the rain is not a true biconditional statement, but this one is. I have a triangle P. I have a triangle if and only if my polygon has only 3 sides. The you can reverse that and say my polygon has only 3 sides if and only if I have a triangle. So you can go both ways with this. You can also take the negation of P and Q. If you say I don't have a triangle if and only if my polygon does not have just 3 sides. And then my polygon does not have only 3 sides if and only if I don't have a triangle. Sometimes it can be a little confusing trying to figure out how to say this in English. Okay, now a question in our homework. Complete the truth table for these statements. First of all, we have P and Q, and you just have all the combinations of true and false. And you want to look at the P or Q, and it will be true if either one of them is true. So we have a true. This is a true and a false. So one of them is true, so it's true. We have a false and a true that gives us a true. But if you have a false and a false, you have a false. Now for the intersection, both must be true. So if you have a true and a true, you get a true. For all the rest of them in which one of them is at least false, you get all false. Now for the conditional, if P then Q, then for that one, you just know that if you have a true and a true, you get a true output. If you have a true and a false, you get a false output. But if the antecedent is false, you don't have enough evidence to prove it false, so you call it true. And finally, the biconditional truth table have to be both true or both false. So when we have a false and a false, we get a true and a true, we get a true. And if you have a true and a false and a true, we get false. Now here, I think you just need to memorize this because you can get them mixed up. If you have the original statement being Q, if Q then P, we want to identify the inverse, converse, contrapositive in the original statement. Well, obviously the original statement is Q, if Q then P. The converse is if P then Q. The inverse is when you take the negation of both. So if not Q, then not P. And the contrapositive is just to reverse the inverse. And if you got if not P, then not Q. So now I say complete the truth table for the following compound statement. And what I've done to illustrate this is we need to, first of all, put down P and Q, and then have the not P and not Q columns. So we take not P and the not Q, obviously the true becomes a false and the false becomes a true. And then to look at the biconditional of not Q and not P, if they're both false, we get a true. If they're not both false or both true, we get a false. So these two are false. And then the two true ones yield a true. Complete the truth table for the following compound statement. This is a biconditional Q, and looks like a negative, but that's really not P. So let's put down P and Q, and then put a column of not P, and that gives us a false, a true, and a true. And now we need to look at the biconditional where you have Q and not P as inputs. Here again, the biconditional, to get a true, you have to have both false or both true. So we have a false here, we have a true here, and we have a true here because the inputs are true, and we have a false here. And make your head spin, can it, Miranda?
Yes, sir.
Yeah. Fill in the blanks here. P and Q, we want to do the OR, so we get true, 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 and then false. And now we want to fill this one in. So what I wanted to do was put a column of not Q over here. I created another column of not Q, and just looking at that, that would be false, true, false, true. And then I wanted to write down, repeat P and Q, and that's true, 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 false. And now we can do the if not Q, then P union of Q. We got P union of Q here. So notice if we have a false and a true, it becomes a true because if the antecedent is false, we can't prove it one way or the other, so we accept it. If the antecedent is true and the consequence is true, we get a true. And in both cases, in this last case, or next to the last case, if the antecedent is false, we'll get a true. And finally, if the antecedent is true, the consequence is false, then the conditional is false. Did you get this one on your practice test?
Yes, sir.
If horses have 6 legs, then Benjamin Franklin was the first president of the United States. Well, the P is horses have 6 legs, and the Q is Benjamin Franklin was the first president of the United States. Now we know that Benjamin Franklin was not the first president of the United States, but we also know that if horses has 6 legs, this is false. If that's a false statement, then we really don't have any other evidence to contradict whether Benjamin Franklin was first president. So we call this true. Now we're getting into probability. getting dark outside. I'm going to turn on the light. Hold it a second. You're dealt 2 cards successively without replacement from a shuffled deck of 52 played cards. Find the probability that the first card is a king, the second one's a queen. We know we have 4 kings and 4 queens. On your first draw, the probability of getting a king would be 4 out of 52. The first card, the king. Since you don't replace it, there'll be only 51 cards to draw from, but there'll still be 4 queens. So the probability of 4 kings, of getting a king followed by a queen, would be 1 out of 13 times 4 out of 51, which is 4 out of 663. Okay, this is number 10. No, notice I'm not working all the ones on the practice file. I'll work some more next week. Well, actually not next week, week after next, when you come back from Thanksgiving. But of the 81 people who answered yes to a question, 11 were male. Of the 84 people who answered no, 13 were male. If one person was selected at random from the group, what's the probability the person answered yes or was male? Well, we need to put a table together, and we need to put answer, what the answer was. Either a yes or no. Male, female, and the total. So of the 81 who answered yes, 11 were male. Now that obviously leaves 70 female. Of the 84 who answered no, 13 were male, and that leaves 71 female. So we want to know what's the probability that the person answered yes or was male. Well, there were yes 81, and then 13 that answered no who were male. This was yes or male. So that total is 94. So the probability is 94 out of the total number of people. That would be 81 plus 84, which is 165. So the probability is 94 over 165, which equals 0.5696. And we round that off to 0.57. Now, I think everybody understands factorials. I'm not even sure. I guess we had some on the homework. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. And then 2 factorial is 2 times 1. So we can very easily cancel out these, cancel this out, and the answer is 15. We're having a lottery, but not as many numbers to be drawn. I guess we have 12 balls, and we're going to take 6 numbers from those 12 balls. And so we want the total, how many different selections are possible. That would be simply a combination of 12 things taken 6 at a time. And you can do this on your calculator, and it'll be 924. Now we have a normal distribution problem using the 68, 95, and 99.7 rule to solve the problem. And we have scores on a test are normally distributed with a mean of 105. So I'm going to put 105 here on this normal chart. And a standard deviation of 18. Well, 18 plus 105 is 123. So the mean plus 1 deviation is right here. And then add another 1 and you get 141. And it says what percentage of the scores are greater than 141. So what we want to know is how much of the data is to the right, all the way out to infinity. And what I've done on this chart is, in fact, we're going to fill out even more than you need to work this problem. If you have 68% here, that means you got 34% here and 34% here. If you got 95% from here to here, that means you have 47.5 there and 47.5 there. And then finally, for 3 sigma, you break the 99.7 into 49.85 and 49.85 on either side. Now, if you want to find out how much is on this side, we take 34% and the 13.5%. And we get 47.5%.
Dr. Brown,
Yes.
Mr. Davey joined us, and he's not able to use his microphone right now, but he's been on for a few minutes now.
Okay. Who joined?
It's Jason Davey.
Okay, good, Jason. I'll put you down. But so now the question was, how much is right here? Well, we know that 47.5 is between the mean and 2 standard deviations. And there's 50% to the right total. So subtract 47.5 and you get 2.5%. Does everybody see that? Does that make sense, Miranda?
Yes, sir, I believe it does.
Okay. And so using this data, as long as it's in multiple units of the standard deviation, you can figure out any probability or any percentage. Number 15 has to do with a study. A manufacturer of light bulbs wants to demonstrate the average lifetime of its 75-watt light bulbs. Among 120 randomly sampled selected 75-watt light bulbs, the average lifetime was 1,007 hours. We want to identify the population. Well, the population is what the manufacturer is interested in. It could be interested in all light bulbs all over the world, but to tell you the truth, for sure it wants to look at the 75-watt light bulbs manufactured by the company, not all 75 light bulbs. And the population is not the data or the lifetime, and the population is not the 120 randomly selected ones. It might get some data by taking a sample, but what it's ultimately interested in are its light bulbs that it sells. So the answer is A. Oh, this one is pretty simple. The amount that this guy had saved in each of the last 6 months is shown below. Find the range for the data. The range is going to be the max minus the min, which is 612 minus 117 equals 495. Number 22 is a monthly payment that you have to make for a home mortgage of $88,000 with a percentage rate of 3.7% for 15 years. Well, you'll have this formula for the payments on a sheet when you go into your test. What you just need to do is identify what everything is. PV is the present value or the initial amount of your mortgage. The R rate is in decimal form, which is 0.037. The number of payments you make per year is 12. Notice it says monthly payments. And the number of years is 15. And so plugging in, that's going to be 88,000 times 0.037 divided by 12 divided by 1 minus 1 plus 0.037 divided by 12 to the minus 12 times 15. 12 times 15 happens to be 180. So plug that into your calculator, and I suggest doing it at least twice. Make sure you entered it correctly or you're going to get a bad answer. Well, when you do it correctly, you're going to get 637.775. Rounded off to the nearest cent is 637.78. Evaluate the validity of the chain of conditionals here. First premise is if I pay my bills on time, then my credit will be good. The other premise is what you're going to assume is true. If my credit is good, then I will become a movie star. So the chain here is if you pay my bills on time, then if I pay my bills on time, then I will become a movie star. That is true. But we know that all these premises are not necessarily correct. But if we assume they're true, then the conclusion is true. I'll become a movie star. Miranda, are you a movie star?
Not yet.
But you're paying your bills on time.
So far, so good. Don't jinx me.
Okay. Now, there's only one problem we're doing in this session, one more. Find the probability around the 6 decimal places. Among the contestants in the competition, 41 women and 27 men. If 5 winners were randomly selected, what is the probability that all are men? Well, you need to know the number of ways to get 5 winners from just 27 men. That's equal to combination of 27 men taking 5 at the time. And the number of ways you could get those turns out to be 80,730. The number of ways to get 5 winners from the total of, you got 41 women, 27 men, total of 68 is combination of 68 folks taking 5 at the time. And this is 104,24128. Wow. Over 10 million. So the probability of selecting 5 men is going to be 80730 divided by the 10,424,128, and that in decimal is 0.00774. So that is answer A. Well, those are the problems I was going to work here. We'll be doing some more when you come back from Thanksgiving, and we'll be doing some more the week of the final exam. Does anybody have any questions? I'm going to stop my share. So I see Jason is here. Jason, you doing okay? You can't talk? I guess he could. He's chatting. Okay. Okay, Jason, I'll put you down and give you credit. Even though you did not show your face, that'll be okay. Well, that's the conference right now. Does anybody have a question?
I'm good, thank you.
Okay.
Appreciate it.
Well, good luck to y'all, and everybody have a good Thanksgiving. And I'm going to end the meeting now.
All right, thank you.